So there are different coding styles of Max, which was a study. So out of it, one is a behavioral style. Okay, so what does behavioral style means? Every circuit which we want to model, we write some of its behavior, right? For 2:1 max, which we are trying to model here. So what is its behavior? Its behavior is like when the select line is 0, 0, we will take the input 0, okay, I0 to the output. When the select line is 0, 1, we will take the first input I1 to output. This is the typical behavior of a mux if you want to justify that. That's what is written here. So see typical syntax of module input, how many inputs we have since we are trying for 4:1, I guess it is written. Yeah, it's 4:1 mux. So vector 3 vectors we have taken, 4 vectors, 3:0 means 4 different I we have. One is 0 to 1, that means 2 select lines we have and 1 register. Okay, output should be reg here. Why? Because the outputs which we are assigning are written in always block. So in always block, though you are trying to model a combinational circuit, 4:1 mux is a combinational circuit. So though you are trying to write a combinational circuit, you have to write a reg. Reg we mostly use for sequential circuits, but though we want a combinational circuit here, we need to write it as reg. Okay, so what behavior we are trying to model here is combinational, but it is to be written as reg. Why? Because we are writing it in always block. Okay, we'll see the next coding style which will clear this doubt. So on what things this circuit must change its output. So depending on S or I. So if I changes, there's output must change. If S changes, then output must change. So this is the events. Okay, so on the change of event in S, this happens. On the change of event in I, this happens. Then begin. Then case S. Why S is written here? Because whatever thing we are trying to model is depending on S. So whatever conditions we are writing inside the case is to be modeled according to the S, right? So when S becomes 0, 0, right? At that time, I0 is to be given to output. Output is O. It is written here, right? And when S0 is 0, 1, we write 1. When 1, 0, I2 we give, and when this 1, 1, S is 1, 1, then we give 3 to O. And default, we can keep it as X. X is don't care. As we have covered all the cases, this default is actually unnecessary. We can avoid this. But if we have missed any one of the case, say we can write one default case at that time. Okay, so this is the synthesized RTL. Okay, this is not a technology based netlist. This is RTL. So generally, it has been modeled into this. So this is predefined in the library mmux underscore 0101. So it has one select line which is vector, 3 different inputs, data 1, data 2, data 3, and one result as output. Okay, so next we have data flow or logical based. So actually this is uh, more like purely combinational. Why? Because in combinational circuits we use assign. So when we use assign statement at that time, this is more combinational oriented, right? So these things remains same as we have seen earlier. Now assign O means output. This is our output. So now on from basic digital electronics, we know that what is the output expression of 4:1 mux. You can Google it and just see that. Okay, so it's like I0 S0 bar S1 bar, that is being written here, right? You can check that. And then we add, then S1 bar we do, then S0 we do, not bar, okay, S0, then I1. In this format we write the equation. So that is being modeled here. This plus is given with bar, which is OR operator in Verilog. Okay, so in this format the whole output expression you can write. So this data flow logical style is Boolean expression based, and this is mostly used for modeling a combinational circuit. It's not flip-flop. Flip-flop we can't model using a sign. It's totally rubbish thing to talk about. Structural. So structural means everything we talk in terms of gates. Okay. So these things remain same, complete. Now this is the structure what we have. It consists of OR gate, 4 AND gates, 2 NOT gate. This is basic digital electronics we know from it. So you draw this circuit and now we need to model it. So now what wires we have? Wire is what? Wire is simple wire which we know from our electrical or anywhere which you have seen. So that is a kind of a bridge. Okay, we connect one signal A to B, so this we have to declare as wire. But when A is input port, B is output port, at that time there is no need to take a wire and Verilog. But when what happens generally that this is input port, okay, this is input, then there is one, say, let's forget of this. There is one NAND gate and then it is connect AND gate and then it is connected to some NAND gate. Okay, this is your output. Oh, this is your input A. Now this wire you see, this one. So this is intermediate. This is not connected to the input, okay, directly. This is connected via AND gate, okay, but not connected directly to input, and it is neither connected directly to output. It is actually connected to NAND gate. So this is an intermediate wire, right? When anything is intermediate, you need to declare it as wire. This is very important. Okay, these things are directly from the input ports, right? Say this is also from input, some input, this one input. Okay, this is okay. This is directly connected to your output port, output block, okay, output part. Then okay, no need. This we have already covered here. But what about these things? These are intermediate. So you can see here. This is directly connected to the input port. No need to declare that wire. But Y0, Y1, Y2, Y3, these are not connected to directly your output, right? These are intermediate. It starts here and ends here. That's why these things are, these four are to be declared as wire. That's why we have declared it Y0, Y1, Y2 as wires. Okay, then also this you can see these two are wires. Okay, because those are also intermediate. So two wires we have taken. And then these are the primitive gates. The word is very important. Primitive gates, not and. When you see a gate level netlist, GLN, gate level netlist, at that time everything is modeled in terms of primitive gates. Okay, this is predefined. What is syntax of primitive gate? And then you write output, then you write inputs. How many input does it has? We don't know. As per your design, any input it can have. But first needs to be output. First वाला हमेशा output रहेगा and rest of the things will be input. Number of inputs you can have, but output should be one. It's pretty obvious. Any gate has only one output. So in this format, this is written. So not N1. N1 is a name. Any name you can give. You can write your own name also. NS0 is the output. NS1 is also output. And Y1, Y1, all are outputs of these gates. For this and A3, Y2 is output. So you will check this. This we will see. Okay. So where is A3? Is it written A3? No, it's not written. So Y2 we will check. Okay, Y2 is output, obviously. First one is the output. Where is Y2? This is the Y2. So this is output of this AND gate. So this is A3. Okay, three inputs it has. One is coming from I2, second is coming from, I guess, this S1 and some other. So in this fashion it is written here. So for I2 it is there, S1 it is there, and some NS0, from NS0 it is coming, another output. Okay, NS0 is here. Yeah, see, this is the NS0 which is coming. So when you draw the diagram of it, you will get to know. This is the NS0 which was our wire. So in this fashion, take one gate, see what output it has, write it in N3 as you have taken, and Y0 right. Okay, and then see what input does it has. Here for this gate I am writing, okay, N3, consider it as a T, N3. Y0 it is there, then I0 it has, then what does it, this is what, NS1, comma NS1, NS1, and then what, NS0. So in this fashion, see each gate and write it. This actually tool does it automatically. We don't need to see this, but we must know how it is done. Which are outputs, which are inputs, that also we must No, CAG is got the concepts. So this is the structural style which everyone uses in the industry. Why? Because we have the power to know number of gates which we have used. The gate count is important, and using behavioral style, we just write a algorithm based code, right? If else kind of statements, and then we give the total, what we can say, total control to the tool, that okay, I have written this algorithm, you see now how many gates you have to use. Okay, the tool might use 30 gates, but in structural style, if we have thought in terms of digital electronics, then tool, sorry, not tool, then we can use our brains and model that circuit in 10 gates only. Tool used 30 gates. We saved our time, but 30 gates is what the tool gave you as a net list. So 20 gates overhead is there. 20 gates extra you are using for the logic which we are able to do in 10 gates only. That's why the structural style is used. So if anybody tells asked you about structural style, then this is what approach answer you can give. Okay, then vector based is there also for marks. So see module 4 is to 1. This is name. Okay, module is a keyword for any module. Write that. Then this is the sensitivity list. Sorry, not sensitivity. Port list. What is sensitivity list then? This this is your sensitivity list. Inside always block, your whole code is sensitive to S A changes in S or I. When I changes, when S changes, these things will happen. The output will change. That's why it is sensitive to those inputs. Pretty obvious. Right? This is vector based, so it is not that difficult. This we have already written output. Now we have not written a reg. Why? Because we are using assign statement. Okay, assign is yeah, okay. Assign we are using, this is a combinational circuit, combinational style. So when we use assign statement, we don't need to write rec, because output we are assigning using assign statement. So no need to write it as rec. It is combination. It is purely combinational circuit. But when we use always block, then we need to write a rec. So keep this in mind. Too many times students make mistake. This O we are assigning inside a always block. That's why we have written rec. This is the proper explanation. If this O is not assigned in a always block, then what do we have? Different approach is using assign statement. So this is the typical. This you have to kind of learn. Okay, out is equals to in sel inputs and select lines. Okay, in this fashion only you have to write. Now uh, this Verilog has provided a short feature, a shortcut we can say. So any model you can write. If is 16 is to 1 marks, then what changes do you need to make? How many select lines does it need? 4. So here you have to make change, and instead of 1 you have to write 3. Inputs, how much inputs do we have? 16 inputs we have. So instead of 3 we write 15, because it's 0 to 15, total 16 inputs. I guess you got the point. And this remains same, no change in that. Now there is conditional operator, or yeah, this is conditional operator. What is the conditional operator? Some variable is there here, then where some expression is there, then where there is question mark, and then there is another expression, then there are two dots, some expression is there, then two dots, okay, and then the expression 3 in the expression. So some variables say output, so depend on one expression. Okay, when this expression is true, condition, okay, like I is equals to 1, I is exactly equals to 1 or not, that's the expression. When it's true, this this expression 2 is assigned to variable. When this expression 1 is false, okay, when this is false, this expression 3 is assigned to variable. I guess that's pretty obvious. So for 4 is to 1 marks, what do we have? There is a mistake here. Okay, so you can see this part. Uh, this should be Yeah. Let me check it once. Hmm. This should be 0, this should be 1, this should be 2, this should be 3. So what is happening? So you can see it in this fashion. Consider this as one block. Consider this as second block. Okay, this is your expression. When this expression is true, true means 1. When this is 1, and S1 is 1, at that time this will occur. When this is false, this will occur. So now what do we have? When S1 is equals to 1, then we have this block to execute. So we'll see. Now inside this block there is again one conditional statement. So when S0 is 1, this seems right. Hmm. This okay. So when S0 is 1, okay, this is it. S0 is equals to 1. Then what do we have? Oh, I guess this we have to flip. Okay. Hmm. So it is actually like this. This block is here. Forget about this one, okay? Right? So when S1 is equals to 1, at that time we have to go in this block, right? We have seen that part. Now, how many two combinations we have? When S0 is 1. At the time, what you will take this one, IN3, right? So what is the combination now we have for here? S1 is 1 and S0 is 1, right? When S1 and S0 both are 1, 1, then what do we get? We get output as I3. So this is what we are getting. I3 is being assigned to your O. This is what we have written here. I assign O is equals to. In this fashion, now when S0 only, when S0 is 0. Why S0 is 0? Because when S0 is false, right? When S0 is false, it takes the second one, which is IN2, right? So when S1 comma S0 is what? S1 is 1, S0 is 0, that is 1 0. What we must have I2, right? So I to be updated. So now this for this what it is, S1 is 0, right? Only one single 0. So just see this expression once, then you can easily forward. This is like your homework. You do what we will get here. Right? Pretty simple. So these are the different coding styles for your marks, right? Just see. Many times these things are quite asked, and it is very basic. Everyone ask about marks. That's why it's pretty good to study this. Thank you.